Hello everyone, let's dive straight into data loss prevention, or what we call DLP policies. The formal definition describes a DLP policy as a set of rules that administrators use to categorize connectors into business, non-business, and blocked groups to prevent the accidental exposure or movement of organizational data. In plain everyday English, it is the guardrail for your data. Imagine you are a teacher on a school playground. You have a fence around the area to keep the kids safe, but you also have specific areas where they can play with water and other areas where they can play with sand. You don't want the sand getting into the swimming pool. DLP policies do exactly that with your company's information. They ensure that your high security data, like your customer list in Dataverse, doesn't get accidentally sent to a low security place like a personal Twitter account or a public Facebook page. Stay with me here, because even the smartest AI is only safe if it can't accidentally leak your secrets. You've probably seen this at the office, where you try to send a file and the system says you aren't allowed to share this externally. That is a DLP policy in action. Let's break this down together. We are building a safety barrier so we can build apps without worrying about data spills. So now that we've mastered the idea that DLP is our digital guardrail, you might be wondering how we actually sort our tools into those different buckets like business and blocked. Well, that brings us right into our next step, which is connector classification. This brings us to connector classification. The technical documentation defines this as the process of assigning every connector in your environment to one of three groups: business, which handles sensitive data; non-business, for personal or social data; and blocked, for services that should not be used at all. To speak naturally, it is choosing your teammates. The most important rule in the Microsoft world is that a business connector and a non-business connector cannot talk to each other in the same app. Imagine a dummy example. You have a business bucket where you put your Outlook email and your Dataverse database. Then you have a non-business bucket where you put your personal Gmail or Dropbox. If you try to build a flow that grabs a file from Dataverse and saves it into your personal Gmail, the DLP policy will stop you instantly because those two buckets don't mix. You've probably noticed at the office how some apps just don't work together. Often it's because the IT manager has separated them for your protection. Let's break this down together. We are making sure our work life and social life stay in their own lanes. So now that we've mastered how to sort our connectors into separate lanes, you might be wondering what happens when we add AI into the mix and how we keep that powerful brain from talking to the wrong tools. Well, that brings us right into our next step, which is AI Builder and Power Virtual Agents constraints. Now we need to talk about AI constraints in DLP. The formal definition says that AI Builder models and copilots are treated as specialized connectors within a DLP policy, meaning they must follow the same data movement rules as any other business service to ensure generative AI doesn't bypass organizational boundaries. In simple everyday English, it's teaching the brain the house rules. Just because an AI model is intelligent doesn't mean it gets a free pass to ignore the fence. Think of a dummy example. You are building a smart chatbot for a health clinic. You want the chatbot to read patient files from Dataverse, a very sensitive business source. Because your clinic has a DLP policy, you must ensure the chatbot connector is in the business bucket along with Dataverse. If someone tries to add a step to that bot that says, post this patient summary to a public Reddit thread, the DLP policy will shut it down. Stay with me here because we want our AI to be helpful, not a tale teller. You've probably seen this when you use a professional AI tool and it says, I cannot share that information outside this company. That is an AI constraint in action. Let's break this down together. We are keeping our intelligence inside the secure vault. So, now that we've mastered how to make our AI follow the rules of our data buckets, you might be wondering how we can be even more specific and tell the AI exactly which types of info, like credit card numbers, it should never even look at. Well, that brings us right into our next step, which is sensitive information types and pattern matching. This brings us to sensitive information types. The technical documentation defines these as predefined or custom data patterns such as credit card numbers, social security numbers, or passport IDs that DLP policies can scan for to block or alert when the AI attempts to process that specific content. In plain language, it is the digital bloodhound. We are training the system to sniff out things that look like secrets. Imagine a dummy example. You are an HR manager. You build a smart flow that summarizes employee feedback. You add a DLP rule that says if you see a pattern that looks like a credit card number, 16 digits in a row, stop the process immediately. Now, even if an employee accidentally types their credit card number into a feedback form, your AI won't read it or store it. You've probably noticed at the office how a website might automatically put XXX over your password or ID. That is, the system recognizing a sensitive pattern. Let's break this down together. We are giving our guardrails a magnifying glass to see the small details. So now that we have mastered how to sniff out specific patterns like credit card numbers, you might be wondering how to apply these rules to just one test room instead of the whole company. Well, that brings us right into our next step, which is environment level versus tenant level policies. Let's dive into policy scope. The formal definition describes the ability to apply DLP policies at the tenant level, which covers every user in the entire company, or at the environment level, which allows for specialized rules in specific sandbox or production rooms. To put it very simply, it is the big fence versus the small gate. Usually, you have a big fence around the whole company that says, no sharing data on Facebook. But maybe in your marketing sandbox, you need to test a tool that talks to Facebook. In that one specific room, you can create a special rule that allows it, while the rest of the company remains safe behind the big fence. Imagine a dummy example. You are a researcher. Your main office is very strict, but your lab has special permission to use experimental chemicals. You've probably noticed at the office how some departments have different permissions than others. Policy scope is how we manage that flexibility. Let's break this down together. We are balancing total safety with the freedom to build. So now that we've mastered how to apply our rules to different rooms in our house, you might be wondering how to test the fence to see if your app is going to break before you actually go live. Well, that brings us right into our next step, which is testing DLP impact and error handling. Finally, we reach monitoring and DLP impact analysis. This technical area focuses on using the Power Platform Admin Center to see which existing apps and flows would be broken if you turned on a new policy, and how to read the error messages when a policy stops an intelligent flow. In a relaxed classroom tone, it simply means checking the weather before you sail. You don't just turn on a strict rule and hope for the best. You run a report that says, if I block Dropbox today, 12 people's apps will stop working. This gives you time to talk to those people and help them move their data to a business bucket first. As a trainer, I've seen many projects crash because someone turned on a policy without checking. Imagine a dummy example. You are a city planner. You don't just close a bridge. You put up detour signs first. Let's break this down together. As builders, we are the responsible architects of trust. We've looked at the playground guardrails, choosing our teammates in buckets, teaching the AI the house rules, using the digital bloodhound for patterns, the big fence versus the small gate, and finally, checking the weather before we sail. We've mastered DLP policies and AI constraints. You now know how to build powerful apps that the IT department will actually love and trust. Well, that brings us right into our next chapter,